This is a short presentation on the protection of porous mineral building materials. Porous building materials, including terracotta tile, natural stone, pavers and concrete, are incredibly useful materials that we've employed for thousands of years. We use them in floors, walls, kitchens, outdoor areas, building facades and bridges. Unfortunately, they have one major drawback. They absorb liquids, some of which are damaging and reduce the beauty and usefulness of the building material. A close-up of the building material shows the capillary structure through a series of interconnected pores. These aggressive liquids include water, waterborne salts, oils and graffiti. They're able to easily penetrate into the building material because their surface energy, or surface tension, is significantly lower than that of the building material. The building material acts like a hard sponge, so that once the liquid makes contact, it's drawn into the capillary structure through a series of interconnected pores. The result is that the surfaces become unsightly and also deteriorates more quickly due to accelerated weathering and loss of strength. Even after cleaning, the contaminant may still lie below the surface, giving a ghosting effect and encouraging unhealthy microbes and bacteria to grow. There are various ways to combat this problem. Traditionally, a surface coating is applied so that it sits on top of the material. This sort of coating includes epoxy, polyurethanes, and acrylics. They physically stop the liquid from reaching the material, but may have the consequence of making the surface shiny and more slippery when wet. An alternative is the use of an impregnation system, such as the dry treat protective system. This system retains the original appearance, texture, and frictional properties, but still guards against water and oil-based stains by making the surface repel the liquid. A close-up of the untreated section of building material shows even after cleaning, the contaminant may still lie below the surface. A close-up of the surface coating shows how it works by stopping the contaminant from making contact with the surface of the building material. Unfortunately, the coating is subjected to relatively rapid deterioration from the weathering and surface traffic and becomes yellow and flaky. Also, when the coating has to be replaced, it must be entirely stripped off, which is not always easy to do. Another problem is that water vapor in the building material cannot easily escape, so it becomes trapped beneath the coating and it can build up and lead to surface spalling. The impregnation system is unique because it stops aggressive liquids entering the material by chemically reacting with the building material and changing its surface energy. The surface energy is now lower than that of the contaminant. The liquid cannot wet the surface, yet at the same time, it is completely breathable, that is, permits water vapor transmission so that the water does not become trapped. The building material is allowed to dry out, which means it's stronger and more durable. To highlight how the impregnation works, we can compare a treated and untreated section of building material. The treatment is applied as a liquid, usually by a lamb's wool applicator or low-pressure hand pump onto a dry and clean surface. The impregnator is absorbed deep into the material, commonly over 5 mm, where it reacts at a molecular level within the pores. Water falling onto the treated surface is effectively stopped at or near the surface. The untreated side readily absorbs water deep into the substrata. On the treated side, water falling on the surface quickly dries in the sun, helping to reduce moss and mildew, which thrive in damp conditions. On the untreated side, the water remains trapped deep within the material, even if the surface appears dry. The impregnation treatment penetrates deep inside the building material, where it's protected from UV radiation and surface wear. This provides an extremely long life for the treatment. At freezing conditions, the residual water in the untreated building material may freeze and expand by up to 9% of its original volume. This can cause tiny micro cracks to develop. The result is that eventually tiny shards at the surface are able to break off, making the surface rough and, in some cases, unusable. Under sunlight, the residual water in the untreated building material is drawn to the surface through evaporation and with it brings dissolved salts such as calcium hydroxide or lime. Once the water evaporates, these salts are left on the surface where they react with carbon dioxide to form water-insoluble calcium carbonate, an unsightly efflorescence. The treated material has no such problem since salts can only travel when in water. The salts never reach the surface and so are unable to react with the air to form the efflorescence. Unlike most impregnators, the dry treat impregnators consist of nano-sized molecules, that is, a few billionth of a metre in size, which chemically bond deep inside the building material. This provides an extremely long life for the treatment since the impregnation becomes part of the building material. The result is that liquids are no longer drawn into the surface but are repelled. The impregnation system is completely breathable, that is, permits water vapour transmission so that the water does not become trapped. The building material is allowed to dry out, which means it's stronger and more durable. In summary, the usefulness and surface life of a porous building material can be greatly extended by the application of an impregnating sealer. The result is that a treated indoor or outdoor surface is easier to clean and maintain and keeps looking good for longer.